So in this lecture, let's talk about something called power. We already know that work done by a force F in moving something for distance d is given by Fd cos of theta, where theta is the angle between the force and the distance. And let's say you do some work from here, which is time t1 to time t2, then power is defined as W divided by t2 minus t1. So power is sort of a representation and how much effort you put in doing this work. So if you do it faster, then you put a lot of power in doing it, but if you did it slower, that means you put less power in doing the same work. So that's how we define power. But what we just defined is actually the average power. Why average power? Because this W, well, let's define what average power is the total work divided by time taken. So we moved from here to here, did work W, and the total time we took was T2 minus T1. This is sort of an average power. But also, there's something called instantaneous power. Let's see what instantaneous power is. But how much power were you putting in at a particular instant? So for example, let's say you did some small amount of work dW from here to here, and this was done in a very short time interval dt. And instantaneous power then is defined as dW divided by dt. So instantaneous power is nothing but average power, but in the limit when W goes to a small number and dt goes to a small number. We do not talk about bigger intervals like here. We talk about smaller intervals, and this is differential calculus. Okay, let's see how do we write dW. Well, dW is nothing but, let's say we moved a small distance dx in the process. So dW is going to be what? F times dx, because force is constant throughout this interval, dt or dx, times the cos of theta divided by dt. And if you look closely, this is nothing but Fv cos theta, where v is dx over dt. What is dx over dt? The velocity, the small change in distance divided by small change in time. But what is this velocity? This velocity again is the instantaneous velocity. We already know that average velocity is defined as net displacement divided by total time. So that is average velocity. But as we just said, and if you let these things go to small numbers, which means you do not talk about bigger intervals but smaller intervals, then that becomes instantaneous velocity. Like the speedometer on the car is telling you the instantaneous velocity. What is the velocity right now? Or what is the velocity for a very small interval of time in which it's not changing too much. Okay, so this is a standard formula that instantaneous power is given as Fv cos theta. And we'll solve some problems on this in the next lecture.